Hey everyone, welcome to my channel. In this video, let's solve another interesting coding problem, binary tree maximum path sum. So first let us try to understand the problem statement and then we'll see how we can solve it. Okay, so here we are given a binary tree. Every node in this binary tree can consist of either a positive integer or a negative integer. So we have defined a path in this binary tree that gives us the maximum sum. Now what is a path? So a path in this context is a sequence of nodes starting from any node and ending at any other node. For example, if we take 20 as the starting node and 15 as the ending node, then these sequence of nodes give us a path sum of 45. Similarly, if we start a path from this node here and end at this node, these sequence of nodes give us a path sum of 55. If we start a path from this node here and end at this node, we get a path sum of 45. So we have to find the path sum that is the maximum. So this path will give us the maximum path sum, which is 55. So we are worried about the maximum path sum and not the actual sequence of nodes. So how do we solve this problem? The maximum path sum need not necessarily include the root node. For this example here, obviously the maximum path sum includes the root node. Let's change this example a little bit to understand. So let me make this as plus 5 and let's make this as minus 10. Okay, now in this case the path sum, this path sum would be 35 plus 10 is 45, minus 10 is 35, plus 15 is 50. So this would be 50 and this path sum would be 20 plus 5 is 25 plus 30 is 55. So this would be 55. So as you can see, in this case, for this tree here, for this example, the maximum path still is 55, but it is not involving the root node. So it is just this path here, starting from this node and ending at this node. So how do we solve this problem then? If we can somehow compute the maximum path sum at every node, then we can pick the maximum among them and obtain the final result. Now let's dive into one node and look from that node's perspective and see how we can solve this. Okay, now let's look at this problem from node X's perspective. So for this node X, this is the left child and this is the right child and this is the parent. So if we are somehow able to compute the maximum from the left child, the maximum path sum from the left child and the maximum path sum from the right child, then we can use these two values to compute the maximum path sum at the node itself and also find the maximum value that needs to be passed to its parent. Now, what are we doing? We have to compute the maximum from the left first, then maximum from the right next. So what is a tree traversal that helps us in processing the children node first and then does the processing at the node itself? So it is post order traversal. So let's use post order traversal to find these two computations and then we will do the computation at the node itself to find out the maximum path sum at the node and also find the maximum value that needs to be passed to its parent. So let's see how we can do that now. Okay, so for any node we need to compute two different values. The first one is the maximum path sum value at the node and the second one is the path sum value that needs to be returned to the parent of the node. So let's look at the first one, the maximum path sum value at the node. So for this, what we do is we try to compute the sum of the maximum value we obtained from the left node, left child, the maximum value from the right child and the node value itself, the sum of these three, and compare it with the maximum path sum value that we had earlier. Since we are doing it recursively for all the nodes, so this value here, maximum path sum, gets updated every time we find a maximum path sum for a given node. So this also holds the final result. So when we are done processing all the nodes, then this value is the expected maximum path sum value. Okay. Now what is the value that needs to be returned to the parent of the node? So okay, in order to have a valid path sum that needs to be returned to the parent of the given node, we have two different choices. One choice is including the left child and the node, so this path here, and the other choice is including the right child and the node. So in order to find the value that needs to be returned to the parent, so we just compute this sum, the max from left and node X, and this sum, the max from right and node X. So either this sum can be larger or this sum can be larger. So the maximum among these two is passed to the parent. So these are the two different computations that needs to be performed at the node. Once we are done processing all the nodes, this value here will hold the final result. So now let's visualize this taking an example and see how this works. Okay, let's take this binary tree as an example. So let's start from the root node here. So we'll start from this node. Like I said, we'll be doing post-order traversal. So first we'll visit the children node first, and then we'll do the processing of the root node. So we'll start from this node, then we will move to the left node of this node. Now still we are doing post-order traversal, so we'll move down to the left of this node. Now we are at this node. Again we'll move down to the left node of this node. So this value is null. So this node is null, so we return from this node here. Now let's process the right child of this node here. So this value is also null, so we'll return from this node. Now we are computing these two values at every node, the maximum path sum and the maximum from the node that needs to be returned. Now the maximum path sum was initialized to negative infinity, math.min value basically. So here the maximum path sum at this node would be, so this value is 0, this value is also 0, and the total sum would be 20. So the maximum path sum at this node is 20, so we'll update this value here. Okay, and this is the value that needs to be returned as well to the parent. So the value that's being returned is also 20. So let's update this value as 20. Now we are done processing the left child of this node. Now let's process the right child of this node. So now we are at node 30. Similar to this node, so the left and right child of this node, since this is the leaf node, so we don't have to, anyway, even when we visit, so this value will be null and this value will be null. So the maximum path sum at this node would be 30, and this value would be greater than whatever we have earlier. So this is 20. So the maximum path sum is updated to 30, and the maximum from this node returned would be 30 as well. Okay, now we are at this node here. So here we have two values. The maximum path sum from the left node is 20 and the maximum path sum from the right node is 30. Okay, now what is the maximum path sum at the node? So that is this path here. So it is 20 plus 30 minus 5, which is 45. Now 45 is greater than the maximum path sum we have seen so far. So the maximum path sum is 45. And now the value that needs to be returned to the parent of this node. So what is that? So we need to compute this sum and this sum. So this sum is 15 and this sum is 25. So in order to have a valid path, we'll take this path under consideration. So it will be 25. So the maximum that needs to be returned from this node would be 25, sum of these two. So it is 25. Okay, now we are done processing the left node of this node, left child of this node. Now let's process the right child of this node. Okay, so we'll move down. Now we'll process the left child of this node first. Okay, so here the node value is 15. So I'm not gonna process the left and right child anyway because they are null. So the maximum path sum at this node is 15. Is that value greater than whatever we have so far, 45? That is this path sum. No. So the maximum path sum will not be updated, but then what is the maximum value that needs to be returned from this node? It is 15. So let's return 15 from this node. Okay. Now the right child is null for this node. So the maximum path sum at this node would be, this value is anyway 0. So it will be sum of these two, which is 20. Now that value is still lesser than the maximum path sum that we have seen so far. So this value will stay same, but the maximum value that needs to be returned from this node, okay. Earlier this was 15, I didn't update this. Okay. Now the maximum path sum that will be returned from this node would be to the parent of this node is 20. Okay. Now, we have done processing the left child and the right child for this root node. So, what are we seeing? This is 20. The maximum value from the left node is 25 and the maximum path sum value from the right node is 20. Now, what is the maximum path sum value at the node? So, it is 25 plus 10 plus 20, which is 55. So, this is 55. This 55 is greater than whatever we had seen earlier, so I'm updating this value to 55. Now, anyway, we don't have to worry about the maximum path sum that needs to be returned to the parent of this root node. So this is anyway the root node, so we don't have to worry about this. Now, we are done processing all the nodes and the maximum path sum value that we have seen is 55. So that is, this path here would give us the maximum path sum. We don't have to worry about how we what is the actual path, but the maximum path sum that we see for this binary tree is 55. Okay, I'll suggest you to try out some other examples, and if you have learned something new from this video, please do hit the like button. Now let's look at the code.